I'm going to speak to you today about where we're headed with elevators. There's not been really many changes in elevators until about 10 years ago. When Elijah Otis first developed the safety gear, that enabled us to start using skyscrapers where you could actually get elevators to go higher. So there's been some new innovations now, particularly with regards to trying to get more elevators in hoistways, because the taller the buildings become, the more core space is required for the elevators. To be able to do that, there's a number of building blocks you have to go through. Technology has to be introduced slowly but surely to be able to take us to where we need to go. It's also very peculiar that there's such an important portion of buildings, particularly high-rise buildings. The amount of knowledge that's out there, the amount of knowledge that's available to people who are designing buildings, designing cities, is few and far between. It's something that as an industry we really need to do a better job of, and that's educating people, with elevators. For that reason, of course, there's a multitude of consultants that everybody's always fighting with. So, innovations in vertical transportation. You can see that two big changes have happened. With the computers, we've had destination dispatch. Once upon a time, everybody used to press the button, wait for an elevator to come in, you get in and you go off. Now with the computerized destination dispatching, most companies have have destination dispatch, and you'll understand a little bit more why further along the road. But also, to reduce the core space, we're also developing systems where we can get more than one elevator in a hoistway. And that's one of the big steps moving forward, particularly with the last slide you'll see. So what I've tried to do is, with this presentation, I've tried to go through this with 4 fundamental building blocks. The first portion is intelligent building integration, how we can work with the building, with our systems, and give you the tools for customization. It's a strange thing, but it takes longer for people to develop the aesthetics for the elevators because they have to look good in a building, and the signalization has to look good. It takes longer to get that done than it does to actually build the elevator. Elevator security, everybody's interested now in cybersecurity. We're no different because all of our systems are network-based now. So we have to be aware that the building needs to look at this. And control the functions. Give the buildings the opportunity to change the way the elevators run, the way the elevators not run, but the way they dispatch, where they can go to. So you can pull cars out, put cars in, change the groups around. And I'll quickly go through the 4. Anyway, what I was talking about destination dispatch, that's been around since the 60s. The concept was there. But of course, without the computerization, nobody could actually make it function. The elevator industry is very slow to develop or to, let's say, embrace new technologies. There are a number of reasons for that. One is because we have so many restrictions based on us by safety code that everything we introduce has to be very similar to the aerospace industry in some degrees. So anyway, taller buildings wouldn't be possible or practical if it wasn't for the development of the elevator, vertical transportation. We have a building starting down the road here at 1 York, and it's coming out of the ground already. It's going to be 95 stories. It will be the tallest building in Toronto. Actually, the tallest building in Canada. But of course, to get more elevators in there, the more core is required. So one way to reduce that is for a number of years, some of the big buildings, the bank buildings and things in Toronto, for instance, New York, they use what they call double-deck elevators, which is one cabin on top of the other. And they go up and they serve various floors, odd floors, even floors. Pretty inefficient, but it does move people out of the lobby and gets the people up to the floors. Now we've developed, as you can see from the slide on the right and on the left as well, you can also get 2 elevators in one cabin, in one hoistway as well, which we call a dual car, and they run independently. They actually travel on the same rails, but they can go up and down and towards each other, away from each other. And that's all possible because of the changes with the safety codes. We certify all of our systems now to a SIL rating. We use SIL 3, which is safety integrity level. So the difference between if you have one car on top of each other moving, what happens is that you have to have fixed floors. You have to have fixed distances between the floors because people have to get in and out of the different cabins. When you have a dual system, they can travel up and down independently, so you're not constrained by any floor heights, except at the top and the bottom where they come to park, so you can unload the people. The other difference is with a double-deck elevator where you have one on top of the other, you're moving that mass all the time, so it's very power inefficient. With a dual car system working independently, you can park one car. You can, in not busy times, you can just have one of the elevators running. So consequently, they have smaller machines, smaller ropes. So this is a typical building, which you'd have low-rise cars and high-rise cars. We call it twin, and basically you can have both cars in the same hoistway. And you can see at the bottom, it works good for Toronto because we have the path. So you've already got those two levels at the bottom floor to work with. All the running clearances, the distances, there's 4 different levels of safety that's been introduced. The door locks, for instance, also are able to open different door locks at the same time, so you can have one car parked or one car traveling while the other one's releasing the passengers. It's a little cartoon. Not for every building. It doesn't work terribly well, for instance, in hotels, because the transient customers or passengers don't understand the system. They'll only be there for a night or 2 nights, then move on somewhere else. But it works hospitals, office buildings. And as I say, being able to have 2 cars in one hoistway reduces the amount of core. And you can see the concept of the traffic here, and that is that you've got stacked hoistways. On the left is a typical system that we would use it for. You'd have the elevators go up to a sky lobby. You grab the top cars, and you can see on the left, my left, your right, you can see that you've got the high-rise cars and the low-rise cars with a sky lobby up there. And on the right-hand side, you've got stacked hoistways in that side as well. So to make this happen, to be able to get the people to the correct elevator to go to the correct floor, you'll need a different system. You can't just push a button, wait for an elevator to come, and then go to where it put your car call in to go somewhere, because you need to know where they're going to be. You need to be able to predict the travel of the elevators. So by putting destination dispatch system, as I say, all major elevator companies have this now. You actually you have like 25%, 30% better efficiency. You wait a little longer for your elevator, but people travel together, and your travel time is actually a lot less. Now, part and parcel of the future-proofing to make all this happen is making sure that as you develop the systems, on this it's going to be a kiosk, similar to an iPad. You just put them in, you configure the IP address, but they have motion sensors, they've got ambient light sensors, a camera, touchscreen, of course. We've got docking areas, you've got the security devices already built into it. So you can walk up to these now with your cell phone, and even as you're walking into the lobby, it can actually place your calls for you. It knows where you go to. It's kind of a parallel system to the security system. The ambient light means it can turn the screens off, brighten the screens, depending upon the lighting in the building. The motion sensor also tells if people are coming towards it. And you've also got facial recognition built into the system. Now, not all these features are available now. But the point of the future-proofing is that with these kiosks, as these devices, as you move along, you will be able to adopt these new technologies. And as people ask for more systems, more ideas and things, you don't want to throw your investment away and go and buy a whole new system. Hopefully, you put enough technology into it that it will grow with your building. One of the other things with this system is part and parcel of the future-proofing is it's that much more efficient on moving passengers. With this, you'll very, very rarely get into an elevator that's more than 30% full. Very, very rarely. So which means as your building gets more and more populated, it's going to have building ability to adapt with the population and be able to grow, let's say, with your systems. So this is just an idea. You walk up to the kiosk, you touch your floor destination you want to go to. It then tells you which elevator to get into. On a map that comes up on the screen, you board your assigned elevator and off you go. One of the funny things about this, when we first brought this in, people were very social. They would come in off the train, they would get into the lobby, they'd talk. Now they're being told, oh, you've got to go to this elevator, you've got to go to that one. What? And then, of course, people forget which elevator they're told to go to. It's now become the norm. As more and more buildings have these systems built into them, so people are beginning to understand what to do. So this would be a typical building, traditional. People come in. As you can see, the people get off at different floors. On the right-hand side, the same 16 people come in. They take 2 elevators to go to the different floors, which means that your lobby services are much better. The first one that we did actually was the building next door, which is 350 Front. It had so many people coming into the lobby, they couldn't actually get people in the lobby. The first day that we fired up the destination dispatch, and I think this was about 6 years ago, it cleared the lobby immediately. It was incredible because they had 2 sets of turnstiles where people actually came into the lobby. Now this system also allows us future-proofing. One of the other things we can do is because it places the calls, we have systems now where we have robots actually using the elevators. I'm going to show you a very short video, I hope. There was music with this. Do we have any sound? Lynn? Do we have any sound? It's a cute video. It communicates with the elevator system wirelessly. So the robotic system knows where it knows to go to. As it approaches the elevators, it places a call for the floor it's going to, and it just rolls right in. Wirelessly, it's told which elevator to go to. It rolls right in, does its delivery. We're using this. We have a delivery system in San Francisco, and it takes the mail, for instance, and components directly from the warehouse, directly to people's workstations. You see these things rolling all over the place. It's kind of cute. So this is what a wall-mounted kiosk would look like. As you can see, it's similar to very similar to the one I showed you. So, as I say, with these systems, there are no car buttons. If you're using it for fire service or you're using it for independent service for the deliveries, there's a panel on the panel there. It just opens up with a key, and you can place car calls in there. So the next thing you need if you're going to future-proof your building, the next thing you need is to have control over your building. If your tenants change in the building or you change the function of a floor or whatever it may be, most companies now give you the ability to actually change all of your screens. Once upon a time, as I said, it took so long to get the information back to the design people. Then they would have to map the screens using some kind of software. And then, oh no, we don't like that color. So then it would go back again, backwards and forwards. Now you have complete control over the design of the screens. So basically you connect either through a tablet or through a laptop. And you can put your own photos on there. We've done some just for fun. We took pictures of our dogs and put our dogs on the screens. It's basically just using paint. It's just all in your control. You take your photographs of your building or somebody else or whatever. You just load it onto here, and then you just load it onto your screens. You send it through the Ethernet, and it updates all the screens for you. As an elevator company, do we really want to do this? Obviously, because we can make money at this. But at the end of the day, the more flexibility, and our idea is to move ahead to make things more useful and more flexible for the end users. The next big step that we've been dealing with, and that's cybersecurity. We don't have too many with security we do, but as you can see, we've got these kiosks in the turnstiles. So you flash your card, you know where you want to go, it'll place your call, it'll tell you which bank of elevator to go to, and then it'll tell you which elevator to go to as well. Kiosks seem to be, not kiosks, but turnstiles seem to be far more popular in the United States than they are in Canada. But it's only a matter of time before, some of these big complexes they're going up. We're talking about the big building that's going up on Bay Street, 81 Bay, which is going to be the new CIBC headquarters. And they're talking about putting kiosks in there as well because they've got a huge lobby. But the more important part about it is we're working with most of the property management companies now to actually place our system accessible to the IT department of the building. Basically what we do is they tell us now what the address is going to be, so they can contact. For instance, if a developer's got a building here in Toronto, Montreal, wherever it may be, they tell us what the IP addresses are going to be. They're going to allocate for us in those different buildings. We set our IP addresses to suit, and they can monitor with level 2 switches, for instance. They can monitor all our electronics, and if they see a MAC address change on any one of those, they can shut those ports down immediately. So once again, future-proofing, working with the integration of the building. So typically what would happen, this is just somebody swipes their card, it goes to the building network, to the server, it comes back and says, okay, this person's allowed to go to those floors, talks to our controller, we unlock those floors for people to actually place the calls. This is just another path that you can use. '96 elevators in the New York's World Financial Center is just been completed, and of course the World Trade Center has been running for a couple of years now. I actually developed the drive systems and the positioning systems for the high-rise cars, the shuttle cars. They go at they're running at 2,000 feet a minute, and they carry 10,000 pounds in load. Big machines. So as I said, I was just quickly going through the building blocks, So more interest would be where we're going to go now. What's our next steps? Well, one of the big steps now is, I guess everybody's been to the airport and you've seen those long moving walks that sound like, well, they're just noisy because of the technology that we used at that particular time. So now we're using linear motors, and we can make these moving walks now up to a mile long, just on the moving walks. So basically what it does, it starts at the normal escalator speed, and then the plates rotate, and they accelerate you up to 3 times the speed. It's when you're walking in the airport, you're trying to walk fast so you can get past the people who are actually on the moving walks who are standing there. But with these, you can't do it. They're much quicker. So they can move a lot of people. So one of the things that we're interested in now with this technology is to use, for instance, we've got the Google Village coming up in the Don Valley area, and it would be great to have moving walks between buildings, covered moving walks instead of having to walk or going underground even. As you say, they can move up to 9,000 people in an hour steadily. So that was adopting linear technology, linear motors. But there's more than one way to move. We now have elevators that can go sideways. We haven't had any here. Our first one is going to be installed in Berlin, and it will be at the end of 2019, it will be up and running. You can find more information on this on YouTube. They're all available. And as I say, Time magazine voted it one of the best inventions of 2017. We call it multi. We're the only company that makes these sideways moving elevators. So it's particularly useful in, how would I say, innovative buildings. You no longer have to go straight up. You can go sideways, as you can see from the. So one of the things you need to look at is if you're going to go very high, part of the problem is ropes. The hoist ropes, they restrict the amount that you can travel. They also the traveling cables, typically with the elevators, the traveling cable which sends all the information backwards and forwards, they also restrict the elevators. One of the big problems we had at the World Trade Center was the fact that the ropes with the building would sway, the ropes would sway, the traveling cables would sway, and trying to keep it all under control. And on top of that, the higher you go, the more power you're going to require because you're moving more mass because of the ropes. Other companies have come up with different ideas, and that's to use carbon fiber ropes, which reduces the mass that you're actually moving. But at the end of the day, you're still restricted by the amount of sway you're going to have in the buildings. So the next thing that could go, if you can get rid of the ropes, then you can have inclined elevators. You can move them sideways, and it wouldn't limit the design of the buildings. So you can be more creative about the buildings. And of course, moving the cars up and down, buildings, they stretch, they shrink. With linear technology and being able to move the elevators with linear technology, it eliminates those problems as well. And as you can see from the slide on, yes, you're right, these can move in different directions. I hope. As I say, new technology is required. Now, if you go back to what we do in those kiosks, the destination dispatch, where you predict where the people are going to go to, absolutely essential if you're going to have a system that's going to work like this. That was the reason for going through all the other thing. Back in the 50s, the early 60s, actually 50s and 60s, they used to have multiple elevators or multiple cars, but it was like a vertical escalator. So you'd have a box, it would go up, there'd be a box, and they will all over. So you just step into a continuously moving elevator running at about, 25, 30 feet a minute. You'd step into it, the fold would come up, you go up, so whatever floor you're going to. If you wanted to go down, you would go up all the way over the top and down the other side. It was kind of neat, which I never heard of anybody getting injured on them, but nowadays you probably couldn't do it. One of our biggest curses for the elevator industry is cell phones. People are forever walking into doors. Forever. Broken cell phones every day. And of course, it's our fault. But I like this. So anyway, that and the fact that the safety codes have changed means that technology is not available anymore. So the first step we came up with was to put two elevators running separately on the same rails. Increases the movement of the passengers, the traffic flow, and it gives buildings more flexibility. Only problem with that, of course, is you have to have two levels at the bottom, you have to have two levels at the top for parking the cars and getting the people in. So generally you have to add an escalator to be able to get from one level to the other. So as I said, linear motor technology, it's already been proven with the maglev trains, so it's available. It's smooth, comfortable, and very safe. So we call this product, we call it the Multi. I got a video here somewhere.
(1854), the birth of the elevator. This invention changed the way we live. One cabin, in one shaft, on one rope, traveling up and down. A principle that hasn't changed for 160 years. 2003, the twin elevator changed the industry. Two cabins, independently in one shaft. But elevators are still pretty much the same. No significant evolution for 160 years. In the future, more and more people will live in megacities. Today, building development is constrained by the forms of mobility available. A revolution is required. We started to reinvent the elevator concept. What if we were to omit the rope and have a direct drive as part of the elevator cabin? What if we were to provide more than two cabins in one shaft and let them circulate in a building? What if we were to invent a groundbreaking system enabling the cabin to move not only vertically but also horizontally? No more limits in height, shape, and mobility. There are multiple possibilities. And that's why we call it multi.
Oops. So I could have saved my breath, and you could have just watched the video, and I could have watched it with you. But the idea I wanted to put across was that the adoption of technologies in stages make multi possible, and educating people to be able to think outside the box and realize that there are new technologies, there are things you can do with elevators. And as I said right at the very beginning, we do a very poor job as an industry of giving this information to people so that you can think ahead of what you're doing. What am I going to do in 5 years? What am I going to do in 10 years' time? That's the idea of of future-proofing the buildings. So thank you very much.